Hello again, friends. Today in this video we're going to be working with the limit comparison test. So, like the regular comparison test, this test really relies on you having a firm understanding of some of our more popular, famous, so to speak, known series, such as like harmonic series or geometric series, p-series, those more easy to identify like types of series. So the limit comparison test states that if we have two series, let them be A and B, and if they're both positive, and if the limit of the one series over the other exists and is positive, then we know that those two individual series either both converge or both diverge. So let's look at our example here and see kind of how this works out. So in limit comparisons, we're not really making, like in the comparison test, a comparison with an equality. We're going to be using the limit, taking the limit to determine whether or not we have both of our series convergent or divergent. So the first thing we have to do is, once again, figure out, looking at this series, what famous series does it look like? What could it possibly be? Well, if you think of this one, maybe we could rewrite it as a little bit trickier, but let's say we're just working with, let's get rid of this like n garbage. What if we just have n squared over n cubed? What does that equal to? That's 1 over n, right? So in a way, these two series can be compared, and this is our harmonic series, right? And we know that our harmonic series is divergent. So we know that much. So what happens when we take our limit of our two series? So we have the limit as n approaches infinity, and we're going to have our one series over the other. So we're going to put our n squared minus 5n over n cubed plus n plus 1 all over our n squared over n cubed, which is the same thing as 1 over n. So to make this a little bit nicer, we can rewrite this as, I'm going to write it down here a little bit, it's probably going to run out of my stuff, but it's the same thing as n cubed minus 5n squared all over n cubed plus n plus 1. So over here, when we take our limits, we can do our normal like limit determining rules. We can do like L'Hopital's rule, right? And work our way down, and eventually we'll see that this limit equals 1. So what do we know? We know that, looking at our original series, right, this guy is going to be positive because our n squared is going to be greater than this, and for some nth term, right, so into infinity, n squared is going to be greater than our minus 5n. So this top numerator is going to be positive, our denominator is going to be positive, because we have all positive terms going in, right? So yeah, our denominator is positive, our numerator is positive. This guy, all of our terms will be positive, right? Because we're just plugging in positive numbers. So we have two positive series, right? We have a limit that exists, it's equal 1, and 1 is positive, so we have both of those two conditions checked. We know, therefore, that our harmonic series is divergent. So by the limit comparison test, we know that both A and B are both convergent or divergent. So because they're both the same thing, both of them are going to be divergent.